All right, now we want to talk about why is the inside of the Earth hot. But before we do that, how do we know that the inside of the Earth is hot? Well, even the ancient people knew about this because they knew about volcanoes. And so they noticed that this really hot liquid stuff would come out of volcanoes and then it would harden into a rock. And so they knew that the inside of the Earth was hot. Okay, so now that we know that the inside of the Earth is hot, where is all of this energy coming from? Well, some of the energy comes from the sun. So the outside of the Earth, the atmosphere, is heated up by the sun. So if you recall, the sun is a star and it converts hydrogen into helium. So hydrogen is smashed together and eventually becomes helium. This is going to be called nuclear fusion. And so this releases energy, and then that energy travels to the Earth in the way of electromagnetic waves, and then it heats up the atmosphere. So that is why our atmosphere is warm, is from the energy that's coming from the sun. So now let's talk about the inside of the Earth. So the inside of the Earth is not hot because of sunlight. So it's got to be hot for some other reason. Well, the first one is going to be because of the original heat of the formation of the Earth. So if you recall, there were Earth formed as a result of collisions of billions and billions of asteroids. And every one of those asteroids had a certain amount of kinetic energy. So kinetic energy is going to be 1/2 mv squared, where v is velocity. So that the faster an object is moving, the more kinetic energy it has. Also, the bigger the object is, the more mass it has, the more kinetic energy it's going to have. So when all of these asteroids traveling at different speeds and different sizes collided with each other to form the Earth, that released a tremendous amount of energy. And then that energy was turned into heat, and then that helped to heat up the planet. So if you recall, we said that when the Earth initially formed, it was pretty much molten, and so that was from a result of all of these collisions. But if that was the only source of heat, the Earth would have cooled off by now. So there must be something going on inside the Earth that is continuing to heat up the Earth. And that is also, that's going to be radioactivity. So this process here of starting off with two small nucleuses and ending up with one big one is called nuclear fusion. On the other hand, if you start off with a large nucleus, like uranium, and then it breaks apart into two smaller nucleuses, then that's going to be called nuclear fission. And that releases heat as well. So this one's nuclear fusion, that's what the sun is doing. This is nuclear fission. This is what all nuclear power plants on Earth are doing, taking uranium or other radioactive substances, and then as it breaks apart into smaller pieces, it gives off heat. So inside the Earth, it's like a big nuclear reactor. So there's a whole bunch of uranium and thorium and plutonium and all sorts of radioactive elements are inside the Earth. And as they decay, they give off heat, and so that is helping to keep the inside of the Earth hot. There is also one other mechanism that helped to heat up the Earth, and this is going to be called gravitational heating. And so if you recall, we talked about differentiation was when the Earth was in a molten state, the heavier elements, the more dense elements like iron and nickel went to the core, and then the lighter materials went up to the surface. So just like if you take this object and you let go of it, did you hear that sound that was given off by this thing when it hit the table, that's energy. So it had potential energy when it's up here, and then it was being turned into kinetic energy when it hit the table. So similarly, as all of this iron and nickel was going down to the core of the Earth, it was giving its potential energy, was being turned into kinetic energy, and that also helped to heat up the Earth. So those are the three main mechanisms that caused the inside of the Earth to be hot and then keeps it hot inside the Earth. And so you might be wondering, well, why do we care? Okay, the internal heat is what's going to drive plate tectonics, and then it's also what's going to be causing the Earth's magnetic field. The external heat from the sun is what's going to be driving weather on Earth. So it's very important that energy is interacting with the Earth because it's helping to drive all of these processes. Okay, let's take a break. When we come back, we're going to talk about how do we know what is inside the Earth.